Hi guys, Shouvik here. Welcome back to our YouTube channel. So today we'll solve another question from Leetcode itself. So let's get started. So today we have the question, how's Robert Ford? Now on this question, let's first try to understand the question and then we can discuss more on that. But yeah, before we are going to start the questions all together, that is obviously not a medium level question. It is more than medium, I have to say. So yeah, now let's read out the question statement. So on that question, they have given to us, they have given a uh, there are several consecutive houses along a street, each of which has some money inside. There is also a robber who wants to steal money from the homes, but he refuses to steal from adjacent homes. So basically, there is a thief or robber, you can say, who is basically trying to steal money from the list of homes is given to us. So this nums basically stating a list of homes. So there are 4 homes given to us, and there is a special characters of Robert has mentioned, like Robert is not interested to take money from adjacent house. So let's suppose if he done robbing on house number 0, like house and index 0, then he is not going to rob the index 1. He can start robbing from index 2 or onwards, 2 minimum 2 or index 3, something like this. So he is not basically allowed to rob from adjacent house. Now, the capability of the robber is the maximum amount of money he steals from one house of all the house he robbed. Now, the robber has associated with the capability things. And how capability we are stating? We are mentioning capabilities. If the robber steal, let's suppose 5 houses, then he basically, what is the maximum amount he steals? Like what is the largest amount of money he steals from one particular houses? That is going to be its capability of robbing. Correct. Point to note here, like if a particular robber is robbing a house with, let's suppose, cash worth of $3 or $3 million, then basically he is not going to steal a like fragmented portion of that. Like he is not going to take 2.5 or 2 millions of dollars. He is going to take all the $3 million. Like he's entirely steal that particular house. Like if he had like planned to do a stealing on a particular house, he will entirely rob that house. He will entirely rob that particular house. Now it is very intuitive. Like the next line, you are given an integer array nums representing how much money is stashed in each houses. More formally, the ith house from the left has numsi of dollars. So that means this particular house number, house at index 0 has $2, something like this. That much dollars it this particular house had. And I already told that a robber is not going to take a fractional or like any integer value lesser than the dollars present on that particular house. No, he will not going to steal like that. He will entirely steal that particular house. So that is the fundamentals of that question. Now what is given? Now another things is a k factor. What is this k factor? This k factor, you are also given an integer k. So on that question we are also like from the test case we are also getting a integer k representing the minimum number of houses the robber will steal. The robber will steal, representing the minimum number of houses the robber will steal from. It is always possible to steal at least k houses. Now there is a k factor is given to us. So his entire robbery is going to, we are making that a successful robbery. His entire, let's suppose he is planning to rob on today's night. So the number of dollars is present on the series of houses we are giving, and we have asked, hey Robert, can you steal that particular house? What is best suit for you? So the best suit for the robber is he is not going to steal the adjacent houses, and we have enforced another factor. He has to steal at least k houses. Without stealing k houses, we will not consider that is a successful robbery the robber has done. So we want that the robber should steal at least k houses. At least k houses. He can steal more than k, but should be at least k houses. He should have to steal. Right? Now, out of them, we have to return the minimum capability of the robber out of all the possible ways to steal at least k houses. Now, the robber can do various permutations of combinations by skipping the adjacent house robbery, and he is able to steal k or more houses. Now we have to say, we have to return what is the minimum capability, and we told previously the capability of the robber is the maximum amount of dollars he can collect from a particular house throughout its successful robbery cycle. What is a successful robbery cycle? He should able to steal at least k houses. He can able to steal k or more than houses. And what is the capability? If he steals at least k or more than k house, the capability of the robber is what is the maximum dollars he can pull from a particular house. And we have to return out of them all the possible permutations, combinations, what we stated just now. This kind of robbery, we have to tell what is the minimum capability. What is the minimum capability of the robbery he can achieve? What is the minimum capability of the robbery he can achieve? I think you got the gist of the questions, but if not, please read out the questions on yourself and try to understand the test cases. Now let me iterate to you guys to the test cases once. So on the test cases, you can see a nums is given to us and a k factor is also given to us. Now what is given? Now we have to steal, like k equals to 2 means we have to steal at least k house, at least k equals to 2, at least 2 houses. So now try to steal at least 2 houses. So he can steal house 0 and 2, 0, skipping 1, he is stealing 2. So what is the capability on that case? Now maximum of num zeros and nums 2s, that is 2 and 5, maximum is 5. He again tried to steal index 0's house and index 3 house. On that case his capability brings us to 9, num 0 and nums 3. He tried to steal index 1 house and index 3rd house, so his capability is boiled down to 9 on that case also. And what is the minimum out of them? 5, 9, 9, the minimum is 5. Similarly on these test cases you can see, like he have to steal 2 houses minimum. He will going to steal house at index 0 and the very last house. So on that case his capability is going to be 2. And you can build your answer for all such capability. The minimum is going to we can achieve is 2, 1. Right? So I think you guys got the gist of the question. Now first try to like think some solutions to on your own, and then I will tell my approach. So before starting to think to a particular solution, like take a quick look on the constraint. So our constraint of nums dot length is like on the range of 10 to the power 5, and nums individual house can has at max of 10 to the power $9, and k value is going to be nums of length plus 1 by 2. So that is the constraint is given to us. Now from here you can see, if house robber is a very popular questions, like very standard questions for interview perspective, but so that is by seeing this question, house robbery type of questions, we are directly think of the DP kind of things, because we have the choice. We can steal a particular house or we can skip it. We can steal a particular house or we can skip it. Like this way, when we are able to steal particular k houses, at least k houses, then we can try to formulate our answer. But on that case you can see, like how many indexes you have? You have total 10 to the power 5 indexes, 10 to the power 5 indexes. And how much your k factor can grow? Your k factor also can grow in the complexity of nums of length. I have to say it is also some kind of 10 to the power 4, 10 to the power 5. So 10 to the power 5, and if you are creating a DP matrix of size 10 to the power 5 cross 10 to the power 5, so DP is altogether giving you a time and space limit. Time limit exceeded for sure, and if you are storing it in a matrix of altogether of size 10 to the power 5 cross 10 to the power 5, it is going to be an output limit exceed. What it is giving you to be OLE, output limit exceeded. So DP is not going to fit for this particular solution. Now the challenge is going to be arise. So initially we think we have choices. So we thought about DP, but we have at least two parameters changing in DP. One is the index for sure that we have to do, and the k factor. And by changing 2 parameters, we are bringing a time complexity of n cross k, and now n cross k is altogether of size 10 to the power n cross k is of size of 10 to the power 5 into 10 to the power 5, which is altogether giving you a TLE and OLE. So you must have to think something separate out of that DP. Now you have to like leverage your brain. So now what you can think on that. Now one thing is that we can do for sure. Let's suppose for what can I say, for your clarity, I am giving you that is your answer. Like you have some kind of observations from these questions. your answer is somewhere in the bound range. If you are able to point out that your answer is somehow in some range, so your answer is going to be what is the maximum possible answer you can get. You are robbing the house which has the maximum amount of dollars, so on that case you are robbing this house 9 altogether. You are robbing the house 9. And if you are robbing a house 9, then you have to say, if I'm robbing a house of capability 9, then every possible house, and here it is mentioned, it is always be possible to steal at least k houses. That is why question a benefit is giving to you. So there is always a chance you can steal k houses by skipping adjacent house robbing. So you can say, if I rob the house which has the maximum amount of dollars, then I can obviously be able to, I should be obviously able to steal at least k houses. So for sure I will steal very last house which has the maximum amount of money, and then I can keep stealing just before that house, just after that house, and then I can again steal them, and then after very of next index which I just robbed, and the index and the very previous index just I robbed, I will again rob the other. So this way, by this constraints, you are always be able to rob k houses. And what is the answer for that case? The answer for that case to you is, what is the answer for that case? What is your capability? The maximum amount you have robbed from a particular house, and that is nothing but the maximum value of the nums array. So now let's jump on the one note. I am trying to explain to you guys the best I can do, but again, that is, I am repeatedly stating, it is not a medium level question. It is obviously a hard level question, and if you are not able to solve a good amount of binary search on answer topic, then you are not able to identify the questions altogether. It can be solved from a binary search. So please make a patience to me and try to understand the questions, and then please solve the question to your own. Otherwise, you are never, just seeing the video, you are never ever going to get the entire grip of a particular topic. You have to do your hands on the keyboards, otherwise it is a complete waste of your time. So please do submit after seeing the video. Yeah, so now let's understand with the example. So what is given to us? So let's suppose so we have, let's suppose 1 2 5 7 9 3 6 2 2 11, something like anything. So what is not 11? Let's suppose it is like this only, 1. So if you are trying to steal, you say my answer, what is the maximum boundary of answer? The maximum boundary of the answer, the maximum amount can be possible is the maximum amount or dollars is present was the maximum value of nums. That is your maximum answer, because you are able to steal at max that number of dollars from a particular house. Then like this way, how you are able to build your answer? Your k should be always less than your half of n. So that is the for sure. So if you are stealing 9, then steal 6, steal 5, you are stealing these two. Your answer is still in the boundary because you have choose the very highest elements. So you are very good. And now you are again skipping 1 and you are stealing 1 and you are stealing this one. So on the entire range 1, 5, 9, 6, 1, what is the maximum amount you robbed? That is 9. So your capability on this case is 9. Right? So if you are choosing very maximum elements of the very max value of the nums, then your answer is always possible. Now let's try to build the answer with some smaller value. Like we have 1 2 5 7 9 3 6 1 6 2 1. Now let's suppose what is the just lesser value of this? It is 7. So you can take 7, 2, and here you can take 3. You can take 1. How many you are able to take? 2, 1, 2, 3, 4. In this case, you are able to take 1, 2, 3, 4, 5. So by 7, you are able to take how many? 2, 3, 4. By 7, you are able to take 4. By 9, you are able to take how many? You are able to take 5. And again, let me go to some smaller value 1, 2, 5, 7, 9, 3, 6, 2, 1. Now let's try to get some smaller value. Now what is the smaller? 6. Now start from 6. From 6, you can't take 3, can't take 2 because they are two adjacent. Can you steal 9? Now the challenge. Can you steal 9? No. So you are not allowed to make a jump on 9 because 9 is higher. And you on this particular function, on this particular thinking, you are making your capability to be at max 6. So my capability is 6. So that means I can rob at max a house which is maximum of $6. So if a particular house is $9 and if you are robbed that, your capability is going to be 9, but your maximum capability of this particular iterations, you have thought I will make my capability at max with capability 6. Can I build my answer with capability 6? With 9 too we are able to build our answer, right? With 9, how many houses we are able to rob? We are able to rob 5 houses. With 7, we are able to rob 4 houses. Now 6. So here you can see. So from 7 and 9, the array is something like this. With one skipping, you are always landing in such of the indexes which are lesser than or equals to my maximum capability. But for 6, you are landed to a particular index which is more than my 6. So I am not able to rob this house. I am not allowed to rob this house because I have maximum capability of 9. Okay, can I rob this house? No. You not allowed to rob this also because you have the capability of 5. You have the capability of 6. You are not allowed to rob a house which has $7. Okay. So can I rob this particular house? Yes. This particular house has dollars of 5, which is less than 6. So if you rob that house, you are not doing adjacent robbery, and also you are satisfying the boundary. You are not robbing a house which is more than your maximum capability that you think to rob for particular today's night robbery. Correct? Okay, so I robbed 5. Now if I rob 5, I will start to 1. Can I rob 1? Yes, you can rob 1. And from 6, you can rob this one also. So how many you are robbed? You are able to rob house 1, 6 and 5 ko bhi you are able to rob. 1, 5, 6 and 1. These particular 4 houses you are able to rob. Okay, cool. Now let's try to take with some more smaller elements. 1, 2, 5, 7, 9, 3, 6, 2, 1. Now we done 2 with 6. Now let's try to 5. So from 5, can I go to, what is this? That is of 7. My handwriting, man, and this keyboard actually. Okay. Let's keep aside. So from 5, I am robbing house 5. And from 5, can I rob 1? Yes, you can rob 1. Can I rob 9? Can I rob 7? No, it's adjacent. Can I rob 9? No, it's greater. Can I rob 3? Yes, you can rob. Can I rob 6? No, it's adjacent. Can I rob 2? Yes, you can. So considering 1, how many we are able to rob? We are able to rob 1, 5, 3 and 2. These 4 we are able to rob. Now again write 1. Why I am writing repeatedly? The same iteration, same things, multiple times? Because that is how you have to think a particular problems. You have to write every of the iterations to your pen and papers, and after that you will get a particular intuition. So I am also not a superhuman. So I am not exactly know what is the particular algo. If we are able to solve it a binary search, or we have to think of recursions, or we have to think of DP, or a graph based approach can be fit for this particular. No, I am not a superhuman. I am also have to do my own whiteboarding, my own pen and paper work. So I am also giving you the exact test how I am thinking of particular problems, and how just writing few of the test cases, few of the iterations, can you make some common template, some common pattern? Can you make some pattern? Because algo is nothing but a pattern altogether. Algo is nothing but a pattern altogether. Can you make a pattern? From out of that, so that for every valid possible test cases, your pattern should run correctly. Your pattern should run correctly. Can you make some pattern by writing more and more and more of test cases? Can you make a pattern out of that? So how you can build your pattern, how you can build your thinking ability, how you can build your logic building capability. So that test I am giving to you. So that's the reasons you have to write the things to your pen and paper and try to iterate, try to make a formulated things, try to make the questions, try to make your solutions to a particular formulated things. Then only you are able to create your algo for this particular questions. Otherwise you are not able to do so. So yeah, let's go to make some smaller value. 13579 3621 3621 3621. Now we are what we have last taken. So we have taken 5. What is the lesson? Now try with 3. Now you will get your entire test of this particular algorithm. Now from 3 you are not able to do 9 and 6 because they are adjacent. You can try to jump to 7, but no. You can try to jump to 5, but no. You can try to jump to 2. Yes. And from 2 you are not to do adjacent, so you are out. And from 3, 6 is adjacent, you are skipping. You are able to do a 2 jump. So how many you are able to take? 2, 3, 2, 2, 3, 2. These 3 are you are able to take. Now take more smaller elements. 1, 2, 5, 7, 9. What else? 3, 6, 2, 1. 3, 6, 2, 1. 3, 6, 2, 1. Now let's consider 2. If you consider this 2, what? This one you can't because that is adjacent. This 5, can you take? No. This 7, no. This 9, no. This 3, no. This 6, no. This 2, yes. This one you can't. So I think you got the gist. So they are by smalling down your caps or capability, you are able to take lesser houses. You are able to drop lesser houses. And now, so what are all you are able to drop? You are able to drop these 2. And for 1 also you can write your own. You are able to drop this particular one and this particular one altogether, because I don't have to think of adjacent altogether, because all are the other elements are all together my what is the capability I have think to rob this particular night? That is 1. And all the houses have more than $1. So I have ended up of robbing 2 particular houses. And also if these 2 are also adjacent, then I am able to rob a single house for 1. That's the beauty. So stealing lesser houses, so by making your capability lower, you are basically restricting yourself to not to rob more houses, You are very initial, you are a good thief, you are a very kind-hearted robber, because you are not stealing adjacent houses, you are not robbing adjacent houses. So my perspective, you are a kind-hearted robber, correct? So you are a kind-hearted robber, but also you are making yourself a more kind-hearted by making your max capability. You are stating us, okay, I am a very good robber. I need to make my family happy. So that's reasons I want to steal at max from a particular houses this capability amount of money. So and very starting of the year makes let's suppose we have an agreement. You are not basically stealing from adjacent houses. That is a universal agreements that you as a robber we have it. So that you shouldn't have to do for any cases. Now you, for your family purpose, you need to do so to rob at least at max capability of some capability you are stating to us. So okay, so we are allowing to do the robbery to our society. Now let's suppose if you are trying to come with us with a lesser capability altogether. Let's suppose there is a very rich persons to our society, so that particular houses, so you can't ever enter altogether, because your capability you have already decided, and you are entered to our society, and most of the, let's suppose all the houses in our society has more than what is your capability. Then do you think are you able to rob any particular houses? So let's write these test cases. So let's suppose you have we have every houses of our society has $2 and let's suppose you have to take at least you have to rob at least 5 houses. You have to rob at least 5 houses. But you very beginnings of our meetings with the society, we basically invited you as a robber. So you came and you put your agreements that you will do a robbery of max capability of one. So you will not take, you will steal those houses only has capability of one or lesser value, one or less than equals to 1, but you will not going to take, you will not rob any particular house which is more than $1, but all of our society houses of more than $1. So with this agreement, do you think that is a successful robbery? No, that is not a successful robbery. You are not able to rob any single house to a particular society. So now I think you got the gist of this particular question. So we have again a monotonous sequence. So we again have a monotonous sequence. So our our monotonous sequence is an answer. So we will do a search on our answer. So our answer is very start is basically mean of nums. That is the minimum capability houses you can take, and what is the maximum possible answer? That is nothing but a max of nums. And why so? I think I have made you to feel how mean and max should be our lower and upper boundary. You should be able to understand this after the above explanations. If you are not so, then you are not suitable for this particular question. As simple as that. You should be understand what is our lower boundary and what is our upper boundary. What is the minimum? How minimum is mean of nums? Tell me, quickly tell me. If every house is of amount of 2, and if you have the capability of 2, if you are coming with capability 2, and if I have asked you to steal k equals to 3 houses, then you will steal this house and this house and this house, and you are successfully able to do so. So like this way, what is the minimum capability amounts? That is the minimum of nums altogether. That is you can do. If that particular minimum amount, minimum capability you are basically trying to robbery, if that is at least k occurrence and all the k occurrence are not adjacent, so can you able to build your answer? You are obviously build your answer. So that is one example of such test cases. Or these are one, let's suppose these are all 1 and you are entered with capability of 1, then are you able to rob all? Yes, you are able to rob. You are able to rob 1 and you are able to rob k, at least k houses. Correct, as simple as that. So your answer can be like minimum of nums or maximum of nums. So for sure, now you have already get a very blood level understanding of this particular thoughts, that by making your capability lesser, so your answer is basically going to a capability range. So that is what? That is of your capability range. Correct? And when you are making your capability lesser, your number of house robbing count is also going to be lesser. So capability lesser has a direct relationships with number of house robbed. So if your capability is lesser, your number of house robbed is also lesser for sure. So if let's suppose with this particular, if you are doing a binary search, now this particular boundary, and if you have your left boundary and right boundary, and if you have figured out your mid, then you can write your own is possible functions with this particular capability. Can you able to rob k houses? And if you are do so, then that is a valid answer. Then you can try to search some lesser value. You can try to search with some lesser value. If you can rob with some lesser value, because what we have to return on this particular questions, we have to return minimum of capabilities. Let cap 1, cap 2, cap ... n. You have to return minimum of them, minimum of them. So you have to return minimum of all of them. So yeah, now go to the code ones. I think I got you the entire gist, how it is a monotonous increasing sequence and how you are going to get a test of this. So I have created, I have make a nm list, and how I am doing, how I have made it. So I have created a set of nums. So if there are repeated upper boundary, so we are not going to consider it's more than 1. So we have put it in a set. So let's suppose there are 7 occurrence of nums 1. So there are 7 houses of capability 1. So we will do our binary search on minimum boundary and maximum boundary, and what is our feasible answer? Our answer should be any of these elements of nums, any of distinct distinct value of this nums array. So how to make nums as a distinct? By passing it to a sets, and to do a binary search on this, I have to make it in a sorted, to make it is a increasing fashion. All are sorted, all passed with a set, and I have make it sorted. Now it is an increasing sequence. Now I have put my left at 0, right at -1. I have set my index to be -1, and I have written very standard template of my own binary search. If you are following from last 2 to 3 videos, you will definitely get a gist of this till now. So yeah, so I have figured out my mid, how what is the current mid, and if possible to rob this particular house, then though we are doing what, if this robbing is possible, then we are setting our index to this particular mid. This is a possible robbing, and we are searching some lesser value, this is something like this on the notepad. So let's suppose that is the sequence, that is our sequence. So if we are able with a particular, let's suppose k value, if we are able to, so this particular value is valid, you are able to rob greater than equals to k houses, so by increasing your capability, more, this all boundary, this entire range is altogether valid, that is the for sure, because you have the more liability, of stealing more houses, because what is basically shrinking our ability to steal the houses. One is the adjacent factor. Adjacent factor is universal, no matter what patterns the robbery is falling. That is our universal agreement. And another factor is, if skipping adjacent, if he land to a particular houses which has more than his capability, or more than his upper boundary, what he has done, the agreement of the latest agreement the robber has done, then also he is not allowed to do so. Because on the this test cases. So here you can see we have agreements of capability 1, and all the houses has more than $1, then the robber is altogether not do the robbery. So what is basically making it more strengthened? It is basically the capability or the upper boundary. So we have make our upper boundary to a particular k with this particular mid. Basically I have to say, with this mid you are able to rob greater than equals to k houses, so by making your capability more, also you are able to steal k houses, you are able to steal more than k, at least k or more than equals to k houses. That's the for sure. So if that is so, then make your right to mid -1, make your right. So that exactly we did. We make your right to mid -1, and we have set our index to mid. So that is a valid answer. And if it is not, then we have done a standard binary search. We have moved our left to mid +1. So that is something like this. That is something like what? That we are on every video we are stating, if that is a point of invalid, that no, it is useless to check more lesser. It is useless to check. All are invalid. So you have to, your answer should be on the right side. So how you will move your answer? So that is your left pointer. So move your left, that is your mid pointer, to mid +1. Do so, and your binary search will take care of the rest of the things. Correct. Now let's understand. I will tell what is exactly the extra additions or extra check we have to incorporate to our standard binary search. That is a very tricky or trivial test case, I have to say. I am also like faced a good amount of time to tackle this particular test case, but yeah, I will explain. But before that, let's quickly understand the is possible function. So today's is possible function is very simple. So you are passing your upper boundary, that is your maximum capability. So you are passing your upper boundary, that is the maximum capability, the maximum agreements you have done to rob that particular night. And how you can satisfy that? You have basically, how we can do so, we have passed it to a is possible function, and this is possible functions is going to find out, are you able to rob k houses with upper boundary of nm of mid -1? This upper boundary, can you rob at least k houses? Can you rob? I am challenging to rob, but let's see if you are able to rob. So initially we have make last considered. So very starting of the iterations, have we done any robbing? Before starting the robbing, have we done any robbing? No, we didn't. So making it as a false. And till now, how many houses we robbed? This particular iterations, 0. Okay, fine. So now let's start. Now we have iterated to our nums array, what is given to us. And if last considered, so that means we have just steal a last house. So that means we have just steal a very last house, that is the very left house. So that means you are not able to do so because of the constraint of your global agreement with us. Global agreement is you are not allowed to rob adjacent house. So So fine, I am not robbing, but please make me false, because I am skipping one house. I am skipping robbing to a particular house. How will you do so? By making this, because on this particular index, on this particular each, I am not doing any robbing. I am not doing any robbing. So my last considered is going to be false, because I am skipping this particular index. I think that is very straightforward. If you are understand this questions, the entire one note explanation, so understanding why to toggling to a, how we can basically skipping a particular index if we just do a robbing just before of the house is a cakewalk for you. I am pretty confident you are getting this in a full note. But if you are not, if you not understand any of the part of this particular section, please make a comments. I will definitely address on this particular piece. So you are making, so that means you have last considered a particular house, so you don't have the liability to do robbing on this particular index. So but as you are skipping this particular index, so make my liability to be do the robbing na. So I am making your last considered as false, because you have skipped this particular index robbing. Correct? As simple as that. So please make your variables name something like this, what I have named, because that is exactly how industry standard code is something looks like. And you have to write this modular, this readable form of variables or functions, so that it is understandable to your fellow developers. So you have to be practice on this part. And if you does not do a last robbing of the very last index, so you have the liability to do the robbing to this particular house. But with our non-global agreements, you set your upper boundary. So if that particular house is less than equals to your upper boundary amount, then please do the robbing. You have done the robbing. So you have done house rob plus equals to 1. And as you just do the robbing, so make your last considered to be true. Last considered to be true, as simple as that. And now this way, if you are able to rob at least k houses, if your house rob count is greater than equals to k, then why not you are returning true from here itself? You are able to rob k houses with this upper boundary, right? So let's return a true. And the entire for loop executed, and you are not able to rob at least k houses with this particular upper boundary and your adjacent global agreement. So then we are going to return a false from altogether, right? It is, so that is altogether the test of is possible functions. So that is exactly the test of is possible functions. Now there is a very trivial test case I have to say. For that I have to make a this checks to be incorporated to my functions. That is something like these test cases that I am stating you, that is a very test case level executions I have to say. So that is of 1 2 1 3 3. So yeah, let's go to my OneNote. So now try to understand what is the test case is given to us. 1 2 1 3 3. So if you are removing this line altogether na, so if you are removing these lines altogether this particular lines, so this type of test cases can fail. This kind of test cases can fail. So what actually the test case is, how it is not able to handle by the very general binary search template. So what it is doing with 3, it is able to rob this one, right? It is robbed 1, then skip this 1 1 3. So you are, and k factor for this question is 2. You can see also here our k is 2 on this case. So with 3 we are answer equals to 3, it is valid. Now it is search for answer equals to 2. It will search for answer equals to 2. Now with answer equals to 2, it do robbing on this particular house, and it is not able to do because it is more than my capability. So it is able to rob k equals to 1 houses, and there is the constant is we have to rob at least k houses. So with 2 the answer is altogether not possible. And our binary search, we made a template. When a particular point of invalidity we encounter, we are marking the very left everything considering this, everything is invalid, everything considering this, everything is invalid, but that is an edge case. If I can again write 1 2 1 3 3, so here you can see for 1, if you are do from 1, can you rob 1? Yes. Can you rob any after that? No. So you are able to rob k equals to 2 houses. So for answer equals to 1, your answer is altogether possible. But for 2, you are not able to build your answer. So now if you are exactly write the same template, so if you are not able to build your answer for 2, you are not able to check your entire left boundary, right? So that is the case, that is the one case that I have found, like where actually you have to make, because you have to make some kind of checks. You, if you are not able to build a particular answer to a particular index before making the entire left boundary to be an invalid, na, just make if the previous that is of your names of names of or your mid, if your mid minus, oh shit, mid minus 1 is greater than equals to 0, and is possible, if your is possible of nm of mid minus 1 is also equals to false, na, then only reject the very left boundary. Otherwise please consider, because with this I can like think more test cases, like if you have, let's suppose 4 many 4, then let's suppose what I can say 5 many fives, or 6 many 6, and let's suppose we have a 7 of one occurrences with one occurrences, and then we have, let's suppose, only 8. So for 7, correct, I am on the correct board. 8 9 yeah, something like this. So like this way, like if so, as there are only single occurrence of 7, na, if there are only single occurrence of 7, so if you are considered from, let's consider this as a 6 also, so for 7 you can see that for if I have 5 here, something like this, some test cases for which this particular index is starting from this particular index, you are not able to make a left jump, or also if you are able to make a left jump, but all of your right are also greater, all of your right. So here you can see you are not able to take this particular 6, you are not able to take this particular 6, correct, you are not able to take this particular 6 because this 5 and 7 you have taken, so for 7 how many you are able to take, you are able to take 5 and 7. Let's suppose, let's not take very left of this, so you are able to take 5 and 7. So for 7 you are able to build 5 and 7, but if you consider this 5, na, so you can take 5, then 7, then let's suppose there is let's suppose there are one more things, let's suppose there are 4 also here, let's suppose here is 4 also, so I am building my own test case, so building these test cases are also difficult. So you have started your jump from very 7, so from 7 here is a 6 actually, so you took this and you are not able to take this. Now if you are starting from 4, say you are taking 4 6 and 4, let's suppose it is also 4 only, so you are taking this 4, and let's suppose here also it is 4 only, so you are taking this 4. So let me just write it in a good format. So this 4, actually the array is something like this: 4 5 4 7, then again let's suppose 4 is here, let's suppose there is a 4 here. So with 7 you can say, with 7 are you, if how many you can take, this 7 you can take and this 5 you can take. So k, let's suppose your k is 3, right, your k is altogether 3, right. So with 7 you are able to take 5 and 7, and if you are trying to do with 4 5 4 7 4, this 4 and this 4, so you are able to take k equals to 3, but here you are able to take k equals to 2, but k house drop equals to 2, but your k is 3. So you are with 7, now with 7 you are not able to make your answer, so you are all together who are smaller, so 4 is smaller, 5 is smaller, all are 4 5 2 are smaller, so you are all together neglecting, you are not able to build our answer from any of the smaller value, so you can, but you can see that this particular arrangement there is an answer possible. So from starting from 4 you can build your answer. Now Now how that elif block is basically helping you, so write it something like this: set of sorted, so 4 5 4 5 and 7, that is our sorted. So with 5 you are not able, with with 7 you are not able to build your answer. So with 7 you are not able to build your answer. Now can you try to build your answer with some smaller value? But if you are greedy on this way, na, you are all together omitting our left. With 5 can you build your answer? With 5 can you build your answer? You are taking this 5, then you have the upper cap of 5, then you are not taking this 7. Can you take this 4? Yes, you can take this 4. You are taking this 4. So with 5 also you are not able to build your answer. But with this 4, you are able to build your answer. With this 4 you are able to build your answer. So for 5 and 7 it is not possible. So when you are not able to build your answer to a particular index, can you try to make with some smaller value? So let's suppose for this 5, can you try just before the index value, so 5, so I know it is not possible. So you can't directly blindly tell some smaller value it is not possible. You just have to make a check. You just have to try with just one smaller index, because that is one kind of like very haphazard arrangement. I have to say that is very haphazard arrangement where your general template is going to be failed. So just check one smaller elements. So when you are at 5, just check one smaller elements, this 5 and this 5. You are when you are 5, just takes one smaller elements, that is just 4, that is just before of that, and you should be build your answer to for sure. So that is the reasons. If this particular is possible is valid, then we are at very good. Then we are going to check of r equals to mid minus 1, very smaller index. And if our mid minus 1, so that means this elif block is only going to be executed if with this particular index, it is not possible. It is not possible. Then we are going to check. Where we are going to check? We are making to mid minus 1. If my mid minus 1, that is we are standing at 7. Let's on the 7 case, right? On the 7 case. So on the 7 case, with 7 we are not able to build. Can we build with 5? Can we build at 5? We are trying to build at 5. We are trying to build at 5 in this elif block. Let's suppose we are not able to do so. Let's suppose we are not able to do so. Then we are bringing our left to a upper value. But if you are able to build, let's suppose with this particular 5 you are able to build your answer, then you are considering this mid minus 1 to a valid, and you are shrinking your window to r equals to mid minus 2, because mid minus 1 is a valid and you have considered this particular index to your mid minus 1, and you have shrink your window to r equals to mid minus 2. Here we have making mid minus 1 because mid is a valid, then we are searching for mid minus 1. Here we are searching from mid minus 2. So yeah, that's a very extreme case. I have to say, for which you have to write this extra taking care logic. But yeah, after that it is a very straightforward. So without this elif, I have to say it is a very straightforward, and this is possible functions and altogether this binary search and answer. If you really solved a good amount of question on this, then you are able to identify this is a binary search of answer. But yeah, that is quite certain. I have to say it is a very difficult altogether to identify this problem can be solved in a binary search approach. That I have to agree. So cool guys, that's all about the solutions on this particular video, and that is the most optimal solutions to this particular video, this particular questions. And the time complexity, if you are able to understand the entire concept, then time complexity is a cakewalk for you. So we are doing a sorting plus setting things, and we are doing a binary search altogether. So I am not writing every line's complexity altogether. I am writing on the very big term on the today's question. So that is of we are passing it with a set, and we are doing a sorted things. So that is the for sure a factor of n log n, because we are sorting the things and passing to a set. So making a set is altogether a n time complexity, and passing this to a set. So this entire line is going to be taking n plus n log. That is for sure. And here we are doing a binary search, very standard binary search of a size of 10 to the power 5, a size of 10 to the power 5. So that is of log n, and here also we are just iterating. So that is also big O of n log n, and that is also in terms of big O. So how many big O's we have? And here also I have to say we are making two possible calls for every is possible functions. To if it is possible, then to fine, or and if it is an invalid, then we are kind of making an another call to check if our mid minus one is altogether valid or not. If our mid minus one is altogether valid or not, right? So I have to say it is kind of 2 into n log n, 2 into n log n. So the entire time complexity is something like how much? N log n twice plus big O of n plus big O of 3n log n. So that is the time complexity, and if I can take n as a common, this is bring to be big O of n cross 1 plus 3 log n. Right, so that is the exact time complexity of this particular solutions. And your space complexity, I use any extra space anywhere? Let me figure out. I am taking only variables. Okay, I am doing an assignment of nm to nums, so that is going to be a size of nm altogether, like len of nums size of n if all are unique. Yeah, apart from that, I am doing everything in a single variables assignment only. Yeah, on space part only, like a sorted set of nums is going to be take off big of n space. Cool. So that is the most optimal time complexity or space complexity which I am able to come up with these particular solutions. And if you guys are able to understand this particular, because to explain this particular question altogether and the entire solutions is altogether are very challenging for me. And if you have the patience of to understand till this point, and if you really understand these particular solutions, please do subscribe to our channels. Please like the video and please share with your friends, and please do your valuable comments. Yeah, and please turn on the notifications to get the future updates for our next video. Yeah, so bye guys, let's meet tomorrow with another beautiful questions. Bye.